Dear students, I welcome you all in the next lecture of the chapter titled here as Periodic Classification of Elements. Dear students, in today's lecture, I am going to discuss with you one more topic from this chapter, that's trends in the modern periodic table. So, what are the trends in the modern periodic table? Or we can say that what are the trends in the physical and chemical properties of elements? So the physical and chemical properties of elements, how they behave in the modern periodic table, that's valency, atomic size, metallic character, and non-metallic properties. So got it here? So in this lecture I am going to discuss with you the trends in the physical and chemical properties of elements in the modern periodic table. That's what happens to their valency, what happens to their atomic size, what happens to their metallic and non-metallic characters. Got it here? Dear students, as in the earlier classes or earlier lectures, I was discussing with you this modern periodic table. I have already told you that there are 7 periods in the long form of the periodic table or modern periodic table, and there are 18 groups. And these groups start from group first to group 18, and similarly periods they start from group 1 to they start from period 1 to period 7. I have discussed that regarding the elements that are arranged in the periods in the modern periodic table, the elements in a periods they have consecutive or continuous atomic numbers, while as in the groups the elements do not have the consecutive atomic or continuous atomic numbers. Dear students, I have already discussed important points from the modern periodic table that metals and non-metals they have been separated from each other by some group of elements which are known as metalloids, whose properties are intermediate between the metals and non-metals in the modern periodic table. Got it here? Now in today's lecture I am going to discuss here some physical and chemical properties of the elements in the modern periodic table. That means their valency, atomic size, metallic and non-metallic properties of the elements. Now let us first take this, that is valency. What happens to the valency of the elements in the modern periodic table? Dear students, first of all you should know what's valency. I have already discussed it in the earlier classes when we were in the school that valency means the number of electrons present in the outermost shell of an atom, or we can say the number of electrons in the lost shell of an atom. How many electrons are present in the lost shell of an atom? So that is termed as its valency, or in other words, how many elements, how many electrons does an atom achieve when it bonds with some other element? Got it here? So valency is simply, you have to remember it, that it is the number of electrons present in the outermost shell of an atom. यानी आखिरी shell में कितने electrons होते हैं, ठीक है? That is referred to the valency of an element, ठीक है? Now, so you got here the concept of valency. So what happens to this valency? Dear students, on moving from left to right in each short period, the valency of elements increases from 1 to 4 and then decreases to 0. Now understand this point here. On moving from left to right, if we start from left to right in a modern periodic table, or in other words I can say on moving from left to right in a short period, if we take the short period, suppose period number second, period number third, or period number 4, etc. So on moving from left to right in each short period, the valency of elements increases. So valency of elements first increases from 1 to 4, then it gradually decreases to 0. So elements in a period they have different valencies. So from this point, or in other words we can say the valency of the element differs in the periods. For example, here I have taken the example of third period. You know the elements in a third period like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So, sodium, the valency of sodium is 1, the valency of magnesium is 2, the valency of aluminum is 3, the valency of silicon is 4, the valency of phosphorus is 3, the valency of sulfur is 2, the valency of chlorine is 1, and the valency of argon, that is the noble gas, is 0. So it is clear from this third period of elements that if we start from left to right, if we start from left to right in a period, particularly in short periods, the valency first increases. So what happens to the valency? It is the, we can say that it is the property of the elements. So what happens to the valency? Valency first starts from 1 to 4. Like sodium is having valency 1, magnesium 2, aluminum 3, silicon 4. Then this valency decreases to 0. From phosphorus, this is 3. From sulfur to chlorine 1 and argon 0. So from, we can say, valency first increases from 1 to 4 in a short period, then it decreases to 0. So we can say that in a period, elements have different valencies. So in a period, the elements have different valencies. You have to remember, you may be asked in the examination, whether in short answer type question or whether in the MCQ, what happens to the valency? What is the trend in the valency of elements within the periods? So first it increases in short periods. First it increases from 1 to 4, then it gradually decreases to 0. Got it here? So elements in a period have different valencies. Remember this point. Now, so this was the periods. Dear students, if we move from top to bottom, that is down the group, अगर हम डाउन द ग्रुप जाएंगे, फ्रॉम टॉप टू बॉटम जाएंगे, द वैलेंसी ऑफ एलिमेंट्स रिमेन इज द सेम. यानी जो एलिमेंट्स की जो वैलेंसी होती है, दैट रिमेन इज द सेम. फॉर एग्जांपल, इफ वी टेक द ग्रुप फर्स्ट, दैट्स नोन एज अल्कली मेटल ग्रुप, like lithium, like sodium, like potassium, like rubidium, like cesium, like francium. You know that they have got different atomic numbers, but their valency, that means the number of electrons present in their outermost shell. Lithium is having one electron in the outermost shell. Sodium is also having one electron in the outermost shell. Potassium is also having one electron in the outermost shell. Rubidium is having one electron in the outermost shell. Cesium is having one electron in the outermost, and francium has having one electron in the outermost shell. So we can here conclude that when we move from top to bottom, or when we go from down the group in the modern periodic table, the valency of the elements remains the same. So from this point, or from the first, we can say the trend, that is valency. So the valency of the elements in periods does not remain the same, or we can say the valency, the elements have different valencies in the periods. And in that is within the period, if we in any period the valency differs. But when we talk of the valency in a group, when we talk of the valency in a group of elements, that remains the same, which is obvious here with the example, that is group first alkali metals, they are having the same valencies. So in today's lecture, we know that what is the trend of the valency of the elements in the periods, as well as in the groups. So we concluded that valency of the elements changes in the periods, as I discussed it with you, and the valency of the elements remains the same within the group. That means from top to bottom, valency remains the same, and if we move from left to right in a period, in the bottom in a periodic table, valency changes. Dear students, I hope you might have understood this trend, that is here valency. So inshallah, in the next lecture, I will discuss some other trends, some other physical and chemical properties of elements in the modern period, that's atomic size, metallic character, and non-metallic characters. Till then, Allah Hafiz. Thank you very much.